students. I am Dr. ANANDALAKSHMI, Assistant Professor, Department of Chemistry, ANNAMALAI University PG Extension Center, Villupuram. I am going to discuss about water chemistry. This water chemistry is in the first unit for engineering students in chemistry department. Okay. The unit 1 consists of water chemistry and surface chemistry. In water chemistry, we will be discussing about hardness of water, softening of it by ion exchange method, boiler feed water, what are the boiler troubles faced, internal treatment and external treatment, estimation of hardness of water by EDTA method, desalination of brackish water by reverse osmosis, and finally disinfection of water, in which an important topic, breakpoint chlorination. Okay. Now, to begin with, we'll just discuss about the sources of water. We all know rainwater. It's the purest form, but during passage, it gets to dissolved gases like carbon dioxide, sulfur dioxide, chlorine, hydrogen sulfide, etc., and gets contaminated. And if we take about surface water, the first category is river water. It contains impurities like clay, dissolved salts, dissolved gases, etc., organic matter, and etc. So next will be the lake water. It is an impure form because it has high percentage of dissolved salts and organic matter. If you take sea water, the highest salt content is there, and also organic matter is also present in it. Now let us discuss about types of impurities in water. There are so many types. First one is suspended impurities, and the constituents of suspended impurities are clay, mud, organic matter. How to remove it? Filtration, sedimentation, and settlement are the methods to remove it. Colloidal impurities is the next category. Again, the constituents are clay, mud, organic matter, but the size of the constituents vary. That is from 10 to 1000 Armstrong. How to remove this? By coagulation, followed by filtration, or by adding some chemicals like aluminum sulfate, potash alum, sodium aluminate, etc. Now, third type of impurities are dissolved impurities. The dissolved impurities may be gases dissolved in water or some salts dissolved in water. First category is dissolved gases like carbon dioxide, chlorine, hydrogen sulfide, sulfates, and nitrates. Dissolved salts are like carbonates, bicarbonates, sulfates, chlorides, nitrates of calcium, magnesium, iron, aluminium, sodium, potassium, etc. In our unit, in our syllabus, this is the main part we are going to discuss, the dissolved salts, because these dissolved salts of calcium and magnesium are causing the hardness of water. So in our syllabus, we will be keenly discussing about this category. Next impurities will be biological impurities. We all know bacteria, algae, fungi, etc. Okay, these causes very ill effect, pathogenic bacteria are there. So how to remove it? Sterilization. How to do that sterilization? By adding liquid chlorine or ozone treatment, or by UV light treatment, or by adding some chemicals like sodium hypochlorite, bleaching powder, etc. Okay, these two categories are coming under in our syllabus. So we'll discuss this in detail. Now first, hardness of water. What is hardness? To explain hardness to a layman, we can just tell the water which do not lather easily with soap is categorized as hard water. What is that? Water in which you dissolve, if you make rub the soap, it will not produce lather, instead it will produce scum or precipitate. So such waters are categorized as hard water. So hardness in water is that characteristic which prevents the lathering of soap. This is due to the presence of certain salts like calcium and magnesium. Generally, calcium and magnesium salts are responsible for hardness of water. That too, mainly carbonates, bicarbonates, chlorides, and sulfates of calcium and magnesium are responsible. So in total, 8 salts are the key responsible for the hardness of water. Again, I'll repeat: calcium sulfate, calcium chloride, magnesium sulfate, magnesium chloride, calcium carbonate, calcium bicarbonate, magnesium carbonate and magnesium bicarbonate. These 8 salts are mainly responsible for hardness of water. There are 2 equations which is shown here. This shows sodium stearate, which is a constituent of soap, when reacts with calcium chloride, which is a hardness producing salt, will give calcium stearate. It is an insoluble precipitate, that is the scum I said. Okay, it will not lather, instead it produces scum of calcium stearate. If magnesium sulfate is present in the hard water, the magnesium sulfate hardness producing salt is present in water, again that will react with sodium stearate and forms magnesium stearate, which is insoluble precipitate. Thus, water does not produce lather with soap solution readily, but forms a white curd. That curds are nothing but calcium stearate, magnesium stearate, etc. These are called hard water. On the other hand, water which lathers easily on shaking with soap is called soft water. Such water does not contain any dissolved calcium or magnesium salts in it. Now, so hard water and soft water differentiation I have given here. So what is hard water? Which does not produce lather, which contains dissolved calcium and magnesium salts, and it affects cleansing ability of the soap, and due to the presence of hardness producing salts, the boiling point of water is elevated and it is not safe for drinking, and it is also not suitable for industrial uses. On the other hand, soft water produces lather easily with soap. It does not contain any dissolved calcium and magnesium salts. It does not affect cleansing ability of the soap, and thus soap is not wasted. Less fuel and time required for cooking in soft water, and it is 100% safe for drinking, and it is suitable for industrial use. Now, in hardness of water, there are 2 categories: temporary hardness and permanent hardness. Now, let us see what are the reasons, what are the salts responsible for producing temporary hardness. As I said, all salts of calcium and magnesium, that do the 8 salts I said, carbonates, bicarbonates, chlorides and sulfates of calcium and magnesium are responsible for hardness. In this, that is among the 8 salts, the 4 salts, namely carbonates and bicarbonates of calcium and magnesium, are responsible for temporary hardness. Hence, carbonates and bicarbonates are responsible for temporary hardness. This category hardness is also named as carbonate hardness. As the hardness causing salts are alkaline, it is also called as alkaline hardness. So, by any name you can name it. Temporary hardness, otherwise called as carbonate hardness, or also called as alkaline hardness, because they are produced due to the carbonates and bicarbonates of calcium and magnesium. Such hardness, as the name suggests, are temporary, can be removed easily just by filtration or just by boiling and filtering. Okay, temporary hardness leads to the formation of loose deposits of carbonates and hydroxides in the inner surface of the boiler. So these are the temporary hardness. Then what are the reasons for permanent hardness? Chlorides and sulfates of calcium and magnesium are responsible for permanent hardness in water. Since they are chlorides and sulfates, which are non-carbonates, they are named as non-carbonate hardness also, and it is non-alkaline hardness. And these are permanent hardness which cannot be removed that much easily. We have to treat it chemically or by some either physical methods. So permanent hardness leads to the formation of scales. We saw temporary hardness produces only loose precipitates, whereas permanent hardness produces hard precipitates. Okay, we'll discuss it about this in later slides. Next one will be unit of hardness. So for every physical quality, this we have to use units, isn't it? So for hardness of water, there are mainly 4 units available, and in first one is parts per million. It's shortly called as ppm. Okay, parts of calcium carbonate hardness per 1 million part of hot water. If you take 1 million part of hot water, then there is how much parts of calcium carbonate hardness is present? is called as parts per million. Another unit of hardness is milligram per liters. Milligrams of calcium carbonate per liter of hard water. Only these two units are generally used for units of hardness in India, whereas the degree Clark, degree French are generally not used as per India is concerned. Okay, so we'll just concentrate on the first two units of hardness. You have noticed that parts of calcium carbonate. Why we are mentioning only calcium carbonate? There are salts like calcium sulfate, calcium chloride, magnesium sulfate, magnesium chloride, magnesium carbonate, calcium bicarbonate, everything. But all of it, we select calcium carbonate in the unit of hardness. The reason we have to see now. See, degree of hardness, first we have to see. Degree of hardness is commonly defined as the total quantity of hardness causing salts present in water. In unit of hardness, we are mentioning it as calcium carbonate equivalent, isn't it? Why? The reason for choosing calcium carbonate equivalence is the molecular weight of calcium carbonate is 100 and equivalent weight is 50. Hence, the calculation becomes very easy. See, you can see 100 and 50 are round values. So, if you use calcium carbonate as equivalent, then the calculation will be very simple. Not only that, it is highly insoluble in water and precipitated out in most of water treatments. Because of these two reasons, all the impurity salts, hardness producing salts, are first converted to calcium carbonate equivalent hardness, then used in the calculation for calculating temporary, permanent and total hardnesses. Now, there is a formula for calculating equivalent of calcium carbonate. Okay, weight of hardness producing substance present in your water into equivalent weight of calcium carbonate, which is 50, divided by equivalent weight of hardness producing substance. This gives equivalence of calcium carbonate. If you use chemical equivalent in the top, that is 50, in the bottom you have to use chemical equivalent or equivalent weight of the hardness producing substance present in your water. If you use molecular weight for second, you can see in the second formula, equivalent of calcium carbonate can also be calculated as follows: weight of hardness producing substance into molecular weight of calcium carbonate, which is 100, divided by the molecular weight of the hardness producing substances. Now, this will be more clear if we work out this problem. See, there is a question called like calculate the hardness of given sample of water containing following dissolved salts per liter. What are the salts available in the water? Calcium sulfate. It is a permanent hardness producing salt. It is present around 15.2 milligrams per liter. Magnesium bicarbonate is present around 2.4 milligrams per liter. Magnesium chloride is present around 8.5 milligrams per liter. What they are asking? They are asking to calculate hardness of the given sample of water. First step is you have to convert all the salts into calcium carbonate equivalent. So, I have put a tabular column for making the calculation easier. First table, first column has constituents. First constituent I am going to take is calcium sulfate. Quantity available in the water sample, it is as per question, paper question, 15.2 milligrams per liter. What is the molecular weight of calcium sulfate? We know it is 136. So, the multiplication factor, it's nothing but molecular weight of calcium carbonate is 100 divided by molecular weight of calcium sulfate, which is 136. Okay. So we can see 136. 100 by 136, it gives 15.2 is nothing but milligrams per liter of calcium sulfate present in the sample water. So 15.2 into that multiplication factor will give me 11.17 milligrams per liter. So what I have done now, calcium sulfate constituent, which is present as 15.2 milligrams per liter in my sample water, is being converted to calcium carbonate equivalence. Okay. Next category, next constituent is magnesium bicarbonate. Magnesium bicarbonate is present around 2.4 milligrams per liter. So the molecular weight of it is 146. Multiplication factor will be 100 by 146. You know what is 100? Molecular weight of calcium carbonate by 146 is molecular weight of our magnesium bicarbonate, isn't it? So the answer will be 1.64. Magnesium bicarbonate has been converted into calcium carbonate equivalents, and that shows the answer result 1.64 milligrams per liter. Similarly, for magnesium chloride, which is present around 8.5 milligrams per liter, is being converted as 8.5 into multiplication factor 100 by 95. 100 calcium carbonate molecular weight and 95 is the magnesium chloride's molecular weight. Once you have converted all the constituents to calcium carbonate equivalents, then comes the second step. Second step is calculation of temporary hardness. What are the salts responsible for temporary hardness? Temporary hardness is also called as carbonate hardness. So the bicarbonate, magnesium bicarbonate alone is responsible according to this problem. Magnesium bicarbonate alone is responsible for temporary hardness. So straight away I am giving the answer like 1.64 milligrams per liter. Temporary hardness is equal to 1.64. Permanent hardness. Now we have to choose what are the salts responsible for permanent hardness. You can see calcium sulfate and magnesium chlorides are responsible. Chlorides and sulfates are responsible for permanent hardness, we have discussed already. So according to that, calcium sulfate equivalence is 11.17 plus magnesium chloride is 8.94. The total permanent hardness is 20.11 milligram per liter. The both temporary hardness plus permanent hardness gives you the total hardness. Next we'll go to estimation of total hardness by EDTA method. Why we have to estimate this total hardness? See, some industries, if you are working as a lab technician, some industries will bring your water sample and give it to you and ask you to analyze and report temporary hardness, permanent hardness and total hardness, so that it is within the limit, so that they can use this water without treating or without making it soft directly in their industries. So for that you have to calculate the temporary hardness, permanent hardness and total hardness, and for that so many methods are available, but in our syllabus we are going to discuss about estimation by EDTA method. So what is EDTA? You know, ethylene diamine tetraacetic acid is called EDTA, isn't it? So you can see that ethylene diamine, and on both the side amine group is there. In that amine group all the 4 hydrogens are replaced by acetic acid, and the anion of it is having CH2COO minus on the 4 end. Okay, now this will contribute 4 ligands and that will arrest or complex a metal ion. What is the metal ion present in our hard water? Calcium 2+ and magnesium 2+. So by this way the metal ion is complexed by EDTA. The 2 nitrogens and 2 oxygens will contribute their lone pairs, and that will bind the metal ion, namely calcium 2+ and magnesium 2+. Okay, next we'll discuss about the principle of it. What is happening actually? See, water sample is given to you. You have to estimate the hardness present in it. What you are going to do is you will take the water sample and you will be adding to find out the end point. You will be titrating it with EDTA. EDTA is ethylene diamine tetraacetic acid. The sodium salt of EDTA is generally preferred and it is taken in the burette. Okay, at the bottom in the conical flask, you will be taking the sample hard water whose hardness has to be found out. Okay, now to find the end point, generally we used to add some indicator. In this titration, we are going to add indicator, namely eriochrome black tea, EBT they'll call. Okay, alcoholic form, in the alcoholic form. Okay, now what will happen? So once you add the eriochrome black tea, the water to the water sample, the calcium and magnesium cations present in the water will complex with EBT. EBT is also a complexing agent. Eriochrome black tea, which is added as an indicator, is also a complexing agent. So once you add the indicator to the sample water, it will immediately form a wine red color. This is due to the metal EBT complex formation. Now what you are going to do, you are going to add slowly EDTA from the burette and you are going to titrate it. The titration end point is indicated by the color change from wine red to blue color. What is the reason for that? Once you start adding EDTA, each and every drop of EDTA entering is more complexing agent. Okay, EBT, when you compare EBT and EDTA, EDTA is a powerful complexing agent. So when a powerful complexing agent is entering, this metal ions will look for binding with the powerful agent like EDTA. So what it will do, it will cut itself from EBT complex and will pair or will complex bind with EDTA. So this is the reason why the wine red color slowly fades. Metal EBT complex is demolished and the metal will form complex with EDTA. And once all the metal is complex with EDTA, the extra one drop of EDTA entering will react with EBT and that will give you the blue color, which is the end point of the titration. Now for doing this estimation, we have to follow the 4 steps. First, we have to prepare a standard hot water. Okay, using that standard hot water. Second step, I have to standardize the EDTA. EDTA is ethylene diamine tetraestic acid, which is prepared by me, but I have to standard it. I have to know the exact strength of that. That will be the second step. The third step is titration of the given sample water. And the fourth step will be the titration of boiled hot water. Why this step is done? The sample water is given, you are going to do the titration. That titration will give you total hardness. But in the fourth step, I am going to boil the hard water. The given sample water is boiled. While boiling, all the temporary hardness producing salts are decomposed or it is precipitated out, and the filtrate is containing the boiled hot water. After removing the precipitates, temporary hardness producing substances, the filtrate will be containing only permanent hardness substances, isn't it? So titration of that is also essential, and later we'll add both the things to give the total hardness. Now here you can see preparation of standard hot water. You are going to prepare standard hot water. The industry is giving out, that is called a sample hot water. You are going to estimate the hardness of that. But for standardization of EDTA, you have to prepare a standard hot water by yourself. How to prepare it? You have to dissolve around 1 gram of pure dry calcium carbonate in minimum quantity of HCl. Then heat it and evaporate it. The residue is there. You can dissolve the residue in distilled water and make it to 1 liter. Okay. Now this and shake it thoroughly. 1 liter SMF. You are going to collect the dry residue of calcium carbonate and HCl. Okay. Now what has happened is calcium carbonate have been converted into calcium chloride. Now this residue is being washed and collected and made up to 1 liter in 1 liter SMF. Now the standard hot water is prepared such a way that each 1 ml of that solution will contain 1 milligram of calcium carbonate equivalent hardness. This is the main criteria for preparing standard hot water. Whatever standard hot water, you have taken 1 gram of calcium carbonate and you have made into 1 liter after converting into calcium chloride. Okay, this is very important. Each ml of that standard solution contains 1 milligram of 1 ml contains 1 milligram of calcium carbonate equivalent hardness. Second step is preparation of EDTA solution. You take 4 grams of pure EDTA crystals, okay, and dissolve it in distilled water and make up to 1 liter. Third step is you have to prepare the indicator. Indicator here is eriochrome black tea. So dissolve 0.5 gram of eriochrome black tea in 100 ml of alcohol. Fourth step will be preparation of buffer solution. This buffer solution is to maintain the pH. Okay, around the pH has to be maintained around 10. So for maintaining the pH, we have to add some buffer solution, and that solution is also we have to prepare. That is prepared by taking 67.5 grams of ammonium chloride and 570 ml of concentrated ammonia. The remaining is water, distilled water. Okay. Then the fifth step is standardization of EDTA. Now we are going to standardize the EDTA. For that you have to take EDTA in the burette. You wash, rinse and fill the burette with EDTA. Then pipette out 50 ml of the standard hot water. Remember, in the first step we prepare standard hot water. That standard hot water which contains 1 ml, each 1 ml contains 1 milligram, I said, isn't it? That standard hot water is pipetted out 50 ml and taken in the conical flask. To that conical flask, I will be adding buffer solution, 10 to 15 ml of buffer solution and 4 to 5 drops of EBT indicator. Once you added the 4 to 5 drops of EBT indicator, wine red color will appear. Okay, this wine red color is due to metal ion EBT complex. It is a weak complex, of course. Okay, now what you are going to do? You are going to open the burette, slowly titrate the conical flask with the by running down the EDTA drop by drop. Now at the end point, the wine red will have been converted to clear blue color solution. Stop the titration, note the reading, let the volume used for standard hot water, 50 ml of standard hot water, volume of EDTA used for 50 ml of standard hot water be V1 ml. Up to this clear? Next. This color I have shown here, metal ion Mn plus, maybe calcium 2 plus or magnesium 2 plus. When you add EBT as indicator and the pH is maintained around 10, the metal EBT complex, it is an unstable wine red color. You can see the color in the conical flask. Next, when you treat this with EDTA from the burette, if you add drop by drop EDTA, this metal EBT complex is broken down and metal EDTA complex is formed. Why? This is more stable compared to metal EBT. So metal EDTA complex, it's more stable compared to EBT. This EBT which is coming out is responsible for the blue color. Next step will be titration of unknown hot water, the sample water given from any industry. Okay, directly pipette 20 ml of that sample hot water. You have to add 10 to 15 ml of buffer, 4 to 5 drops of EBT indicator, wine red color will appear. Now titrate it with EDTA from burette. Now let the end point be wine red to blue and V2 ml of EDTA is consumed for that titration. V2 ml of EDTA is consumed for the sample hot water, 50 ml of sample hot water. Next step will be, I will take 250 ml of the sample hot water in a large beaker. I will boil the entire 250 ml of water and reduce it to about 50 ml. During this boiling, what happens? All the temporary hardness producing salts would have been precipitated and settled down. Now I'll filter it and collect the filtrate which has only permanent hardness producing salts dissolved in it. Okay, now from that 50 ml I'll pipette out and take in the conical flask. Again add 10 to 15 ml of buffer, 4 to 5 drops of EBT indicator, wine red color will appear. Now as I titrate with EDTA from burette, the wine red color will turn to blue. That end point, let it be V3 volume. Let V3 be the volume of EDTA consumed for 50 ml of boiled hot water. So 3 sets of titrations we have performed. I repeat again, first set of titration is with EDTA and standard hot water, okay, prepared by me. Second is EDTA and 50 ml of sample hot water given from the industry. Third titration is EDTA versus 50 ml of boiled sample hot water. Okay, now let us see the calculation. So whatever I said, it is summarized here. Let V1 ml of EDTA solution is equal to 50 ml of standard hot water. Let V2, second set of titration, it is equal to 50 ml of unknown sample of hard water. Let V3 ml of EDTA solution is equal to 50 ml of boiled hot water. Okay. Now, I am going to calculate the strength of EDTA. Step 1 is to calculate strength of EDTA. We know the strength of EDTA, the standard hot water contains 1 ml of standard hot water contains 1 milligram of calcium carbonate. Therefore, 50 ml I have taken, isn't it? So, 50 ml of standard hot water will contain naturally 50 milligrams of calcium carbonate. Let this be equation 1. Also, 50 ml of that standard hot water when used in titration consumed V1 ml of EDTA solution. Let this be equation 2. So, from equation 1 and 2, we come to a conclusion that V1 ml of EDTA solution is equal to 50 milligrams of calcium carbonate. That is, therefore, 1 ml of EDTA solution. Okay. Therefore, 1 ml of EDTA solution is equal to 50 by V1 milligram of calcium carbonate equivalent. Do you follow? V1 ml of EDTA solution is equal to 50. Why V1 is equal to 50? I have taken 50 ml of standard hot water. 50 ml of standard hot water has 50 milligrams of calcium carbonate hardness. Therefore, 1 ml I have to calculate. For 1 ml of EDTA, 50 by V1 milligram of calcium carbonate equivalent is there. Okay. In second step, I am going to determine the total hardness. The sample water as such I have taken and I have titrated. Second set of titration, isn't it? So, 50 ml of hot water, sample hot water consumed V2 ml of EDTA solution. Let it be 3 equation. But we know 1 ml of EDTA is equal to 50 by V1 milligrams of calcium carbonate equivalents. Therefore, V2 ml in the second set of titration, V2 ml of EDTA was consumed, isn't it? That is equal to 50 into V2 by V1 milligram of calcium carbonate equivalents. This is fourth equation. So, from equation 3 and 4, we come to a conclusion that 50 ml of sample hot water contains 50 into V2 by V1 milligrams of calcium carbonate equivalent. Always ppm or unit of hardness is spoken in terms of liters, isn't it? So, 50 ml contains this much means 1000 ml, that is 1 liter of sample water may contain 50 into V2 by V1 into 1000 by 50. This will give you total hardness present in 1 liter of water, isn't it? So, here you can cancel 50-50 in the numerator and denominator. Finally, you get V2 by V1 into 1000. So, the total hardness is calculated using the formula V2 by V1 into 1000 milligrams per liter. Okay. Next. In the step 3, determination of permanent hardness. We know third set of titration, we found that V3 ml of EDTA solution was consumed. V3 ml of EDTA solution was consumed for 50 ml of boiled hot water. Remember, we have boiled 250 ml, reduced it to 50 ml and filtered it and taken only the filtrate. So, what is there? Only permanent hardness producing substances are there. Remaining temporary hardness producing substances are being removed due to filtration or boiling and filtration, isn't it? So, we know from the first step, 1 ml of EDTA consumes 50 by 1 milligram of 50 by V1 milligram of calcium carbonate equivalent. Therefore, V3 ml of EDTA solution from titration 3 will be equal to 50 into V3 by V1 milligrams of calcium carbonate equivalents. From equation 5 and 6, we have concluded that 50 ml of boiled hot water contains 50 into V3 by V1 milligrams of calcium carbonate equivalent. Therefore, for 1 liter, 1000 ml of boiled hot water, we have to calculate like that because we have to report per liter, isn't it? So, 50 into V3 by V1 into 1000 by 50. So, cancelling 50 on both the sides, then we finally arrive the permanent hardness is equal to V3 by V1 into 1000 milligrams per liter. So, by this way, we have got two formulas for calculating total hardness and permanent hardness. How to calculate the temporary hardness? temporary hardness is equal to total hardness minus permanent hardness. So V2 by V1 into 1000 minus V3 by V1 into 1000 will give us temporary hardness. Taking the common terms outside, that formula will become 1000 into V2 minus V3 by V1. Now, this will be more clear if we discuss a problem. See, I have given 3 problems. Okay, let us take one problem and discuss. 50 ml of standard hot, first problem I am discussing. Okay, 50 ml of standard hot water containing 1 milligram of pure calcium carbonate per ml consumed 20 ml of EDTA solution. See here, standard hot water, first set of titration. So V1 is what? 20 ml. 50 ml of the given sample water required 25 ml of same EDTA solution. This is second set of titration, which means V2 is what? 25 ml. Third set, after boiling, 50 ml is taken and it required 15 ml of EDTA solution. This is third set, which means V3 is equal to 15 ml. Now what you are asked to calculate total, permanent and temporary hardness of water. So here I have discussed the details. From step 1, we have calculated that 1 ml of EDTA solution is equal to 50 by 20, which is 2.5 milligrams of calcium carbonate equivalent. From step 2, we have concluded that total hardness, you can check it, okay, 1000 into V2 by V1. So what is that? 1000 into 62.5 divided by 50. 62.5 divided by 50 gives you the total hardness as 1250 ppm. From the third step, you can calculate the boiled, which will give you permanent hardness salts. Okay, permanent hardness. So permanent hardness is coming around 750 ppm. So temporary will be total minus permanent, which is equal to 500 ppm. You can go through the problem. Okay, and I have given the remaining problem also. So let us finish up to this. In the next video, I'll be discussing about how to remove the drawbacks of hard water. Okay, we'll also discuss this if possible in the next video, and we'll see how to remove the hardness by external treatment, internal treatment. So many things are there. Okay, thank you.